Hello and welcome to section 1.6. We're going to discuss complex numbers. And I'm going to start things off this way by solving a quadratic equation that, you've probably solved stuff like this in the way that I'm going to do here. So x squared equals 36. The easiest thing to do is probably take the square root on both sides. So let me squeeze in a square root here and one here. Of course, on the right-hand side, there's two square roots of 36, the positive one and the negative one. So we'll account for that and end up with plus or minus 6. But in the 15th century, actually 16th century, 1500s, mathematicians started experimenting with some other stuff for similar problems with a little bit of a difference. And that difference is that all of a sudden we had to deal with things that had a negative here. The problem is, what's the square root of a negative number? Now, in my Math 1150 intermediate algebra class, I used to call that NARN, not a real number. For reasons that elude me, it hasn't caught on with the wider math world, but we soon got past NARN this way. On the left-hand side, that's just an X. On the right-hand side, we did this. We rewrote that to include the square root of -1. When you include the square root of -1, that offers us the opportunity to make a little definition here. We're going to call that I, as in imaginary. Now, with that simplification, we end up with plus or minus 6 times I as the answer to this. So, wow, that kind of works out, doesn't it, I guess? It's based on the idea that the square root of -1 is I. And that means if I square both sides, I end up with -1. And that's the important and amazing fact about I, is that I squared is a negative number. Now, this is not just the imaginary kind of thing that people in the 16th century thought. It's actually a part of our real universe. In fact, kind of a fun part of complex numbers is that they're part of a lot of fractals. And you can see, look up fractals on the internet. Here they are. They're just beautiful. A lot of times they involve complex numbers, and they're just really, really cool. You don't even need to understand the math that underlies them to appreciate that these are just some pretty funky and cool images. So in any case, back to our work with complex numbers. With this definition here, we can start solving a lot of equations that we weren't able to solve before. Now, as I mentioned, this is part of a complex number. So let's talk about what complex numbers are. So complex numbers have this form, in the form of A plus B times I. Of course, I is still the square root of -1 that it was before. But A and B in this case are just real numbers. Now, that does break things up into what's called the real part here and the imaginary part here. So there's two parts to one complex number. But, that's okay. There's different applications for the real and imaginary part depending on what branch of physics or electronics you're working with. So A plus B times I, there's your real part, and that's the imaginary part. Now you're going to see problems in the homework that are like this. You're going to have a number, for example, 3 plus 5 times I, and they're going to ask you for the real part. So the real part is just the 3. The imaginary part, the imaginary part is the 5. The I is kind of like implied with that. I don't think you have to put the 5i for the imaginary part. It's just the coefficient of the imaginary part is what they're looking for. Now, sometimes you'll be asked to do a little bit more thinking than just that. So you could have 4 minus 7i over, say, 9, something like that. And the first thing you would do is you'd kind of break it up. Is to 4 over 9 minus 7 over 9 times I, like that. And now you can peel off the real and imaginary parts. Of course, that's your real part, and that's the coefficient of the imaginary part. Just the minus 7 over 9 times I. Don't include the I, all right? Just looking at the coefficient. Because it's the imaginary part, we know that the I is there. So that's your real part. This is your imaginary part. So hopefully a couple quick, easy points for you on an exam. Now, our goal is to do a lot of work with complex numbers. So that's going to include add, subtract, multiply, and divide, amongst a few other things. Let's start with this example. That'd be, let's do 6 plus 8 times I plus 9 minus 4I. So you're adding two complex numbers. This is a complex number and this is a complex number. Okay, not a big deal. The idea behind this, though, is you're going to add up the like parts. For instance, that's the real part. We'll add those things together. And this is the complex part versus the imaginary part. We'll add those things together. So 6 plus 9, that's going to be 15. 8 plus negative 4 is a positive 4. And that's it. So you added up the real parts. We got 15. You added up the imaginary parts, and we got 4I. Perfect. What about subtraction? Well, subtraction is not much different. So let's do an example of that. 12 minus 3I minus 6 minus 2I. I guess the thing that I would suggest here is that you distribute that negative sign. So it would turn into 12 minus 3I minus 6 plus 2I. So now that I've got that taken care of, now I can add up the same thing that we did before, that is the real parts here and the imaginary part here. So 12 plus negative 6 is 6, and negative 3I plus 2I is a negative I, or a negative 1I. You don't have to write the negative 1 there. If you'd rather, you can just write 6 minus I. Beautiful. Well, we're going to have to go a little bit farther than just this. Let's keep going and work with multiplication. Now, before I move into some problems with multiplication, I want you to recall something. What does I squared equal? Good job. -1. I squared is -1. That part is going to be central to multiplication, division, and exponentiation of I. And by exponentiation of I really mean I raised to higher and higher powers. Let's start with this example. 6 minus 5I times 2 plus 3I. Now, it might look like the product of two binomials. In fact, that's how we're going to treat it. We're going to FOIL this out and get our answer. So 6 times 2 is going to be 12. Then the outside is going to be 6 times 3 is going to be an 18I. Inside, minus 5 times 2 is 10. Don't forget about the I, 10I. And then the last one, you've got a negative times a positive, which is negative. 5 times 3 is 15. And don't forget, you got I times I, which is I squared. That's probably the easiest mistake to make, is to forget to square that last term. Well, let's see. We got some like terms that we can combine. Those are like terms, so that's good. So we get 12 plus 8i. But now this minus 15i squared is going to change. Because remember, I squared is -1. So that's really like minus 15 times -1. And minus 15 times -1 is really just plus 15. And now, these are like terms. I can add those together. I end up with 17 plus 8i. Beautiful. That's exactly what I was looking for. Now I'm going to let you in a little secret. You can check this with your graphing calculator. It's pretty nice and it's pretty easy. So let's do it. Let's see, I wanted 6 minus 5i times 2 plus 3i. So I'll start with a parenthesis, 6 minus 5 times I. Now I is right here above the decimal. If you see it there, it's kind of small, it's in blue lettering. And if I want the blue lettering, I gotta hit the blue button, which is the second key. So second I, then parenthesis, another parenthesis. This time I want 2 plus 3i. So again, second, and then the parenthesis. There's gonna be second and then period, then a parenthesis. And you kind of see all my keystrokes down here. If you want to take a quick look at them, this is exactly what I've typed in order to get this expression. So let me bring that down a little bit. When I press the enter key, bam. Whoops. Where did I? Oh, I made a typo, didn't I? Yeah, I just added the 5 and the 2. I forgot. That should be a 27. So the cool thing is, just like me, you can check your answers and make sure that you got them right. Now, on an exam, I want to see the work. I want to see this stuff here. But I just showed you how to check your answer. In fact, for me, it helped out because I made a typo. That would have been embarrassing. Let's continue with another one. Certainly one that you would expect to see on an exam would be something like this. 6 minus 5i. Let's just do that squared. So 6 minus 5i squared. The way I would suggest you work on this is start out by writing it as 6 minus 5i times 6 minus 5i. And then FOIL it out from there. 6 times 6 is 36. Outside terms give me a minus 30i. Inside terms are a repeat of that, gives me another minus 30i. And again, let's be careful with the last term. Minus times a minus is a plus. 5 times 5 is 25. I times I is I squared. Middle terms combine, gives me minus 60i. I squared is -1. -1 times 25 is -25. And I promise to get my arithmetic right in this one. 36 minus 25 is 11 minus 60i. Okay. Let's check ourselves, see that I got it right this time. So let me clear out some of this old stuff. I want 6 minus 5 times I, parenthesis, and then I'll just the square key. Bam, 11 minus 60i. Just what we said it would be. Let's keep going with a couple more here. Now, I want to give you some notation. Let's say Z is this complex number, 3 plus 4i. Then a lot of times we'll find it convenient to use this notation. Z bar would be 3 plus 4i bar. That bar notation simply means the conjugate. And what you're going to do with the conjugate is you're going to change the sign on that middle term. So it'd be 3 minus 4i. that's its conjugate. So as another example, we could have 7 minus 2i times 7 minus 2i bar. So I'll multiply two numbers together that are conjugates. So this one and this one. Now that second one really means, excuse me, it'd be 7 minus 2i times 7 plus 2i. And something interesting is going to happen when you multiply a number by its conjugate. Let's see what happens. So 7 times 7 is going to be 49. Outside terms give me a plus 14i. Inside terms give me a minus 14i. And the last one, minus times a plus is a minus. 2 times 2 is 4, I squared. Now, do you see the really cool thing that's going to happen when we try and simplify this? Anyone see that? Yeah. Those terms cancel themselves out. So we're not going to be left with any imaginary numbers. It's going to be 49. This becomes minus 1 times minus 4 is a plus 4. Basically, I end up with 53. Wow, that's kind of cool. Is that really right? Let's check it. So to check it, let me clear everything out here again. 7 minus 2i, and then 7 plus 2i. Should be 53. Beautiful. So keep that notation in mind, because a lot of times you might be asked to do a product of a number and its conjugate, or just simply given something like you are here. Likewise, if I had, well, let's say I've given you both examples. You had a plus, it becomes a minus becomes a plus. So you're just changing the sign on the imaginary part of things here. Well, this last result is kind of handy. We multiplied a number by its conjugate and we got rid of all the complex part of this. This is now just a real number. Although you can think of it as a complex number if you wanted to think of it as 53 plus 0i. There are questions in the homework that do rely on something like this. That is, you realize that, oh, that's really a special case where the imaginary part is 0. But our purpose here is to divide complex numbers. So let's take a look at division of complex numbers with this example. So 6 over 5 plus 2i. Well, mathematicians don't like radicals in the denominator. And even though it's not very apparent, there is a radical in the denominator in the form of the square root of -1. So we don't like to divide by complex numbers. We don't like to leave it that way anyways. So the trick is we're going to multiply this by 1. That is, if I can find a pen that works. So let's try this one. And there we go. We're going to multiply by 1. Now you can't just multiply by 5 plus this plus 2i or something like that and cancel that out, because this isn't an equation. The only thing you can do to simplify an expression is to multiply by 1. And the form of 1 we're going to choose is the conjugate of the denominator. Now see if you can write down the conjugate before I do. What's the conjugate of 5 plus 2i? Well, bonus points to you if you said 5 minus 2i. Now, I'm not just going to multiply by 5 minus 2i in the denominator. I have to multiply by 5 minus 2i in the numerator. So that effectively, something divided by itself is 1. So I'm okay there. Let's see what happens when I do this multiplication. Now, in the denominator, this is just more practice with multiplying complex numbers. So it's 25 minus 10i plus 10i minus 4i squared. In the numerator, well, I'm pretty sure that I'm not going to get any cancellation with the denominator, so I'll go ahead and distribute this. Sometimes I'll wait. 30 minus 12i. There's still a little more simplification to do in the denominator. 30 minus 12i. Hopefully you see the big thing that simplifies, right? You can pause things for a second if you want to try and figure that out. But those cancel each other out. What happens to the minus 4i squared term? Hopefully this is getting a little bit comfortable. It's going to be 25. Well, that's -1. -1 times -4 is a +4. This should always end up as the sum of a couple things. So it's going to be 30 minus 12i over 29. Now, WebAssign might ask you to write it as 30 over 29 minus 12 over 29 times I. They might break it up in that form, or they just might ask you what's the real part and what's the coefficient of the imaginary part, which would be -12 over 29. They could do that as well. But in any case, this or this could be considered the correct answer. On a test, I'll be very happy with this. Now, some places in WebAssign, you might need to enter it like that. Okay, let's try another one that maybe is a little bit more challenging. And if you'd like, you can pause the video and give this a shot yourself. So I'll do another example. That's going to be 7 minus 6i over 1 minus 5i. Now, when I grade your tests, I often give partial credit. And if you just started out the right way, multiplying by 1, the correct form of 1, I'd probably give you at least 1 point. All right, maybe just 1 point, because this is kind of a simple step, but the trick is to multiply by the conjugate. And I'm giving you a chance here to write that conjugate down. What are you going to multiply by? In both the numerator and denominator. For those of you who said 1 plus 5i in the numerator and denominator, kudos to you. All right, well done. Now in the numerator and denominator, you've got a lot of work to do because we have to FOIL it all out. So let's take a look here. That's going to be 7 plus 35i minus 6i minus 30i squared. First, outside, inside, and last. In the denominator, it's going to be 1 plus 5i minus 5i minus 25i squared. Okay, let's see if we can't simplify that a little bit. The nice simplification is going to happen in the denominator. And that happens because those two terms cancel each other out. Very nice. We're just left with 1. And what happens to a minus 25i squared term? Well, that's -1 times -25 is going to be a plus 25. In the numerator, you have some like terms that can be added. That'd be this one and this one. Hopefully you're careful to put an I squared there and realize that, oh, okay, I can't add an I squared term to a term that just involves an I. These are not like terms. 7 plus 29i. -30 times -1 is a positive 30. So I end up with 37 plus 29i over 26. And there's not much more you can do with that. like I've shown you a couple times before, you could, if you wanted to, write it as 37 over 26 plus 29 over 26 times I, splitting it up into its real part and imaginary part. That's fine, but this is good enough. Now, occasionally there's going to be simplification you can do. You know, you have a common factor of 2 for everything or something like that. You can simplify. So that I would like you to do. But for now, I want to work on powers of I. Powers of I. This would be things like I to the 22nd, or I to the 60th power, or I to the 31st power, or I to the 37th power. And we'll finish up with I to the 982 power. Okay. Now I'm going to calculate all of these without a calculator. We can go back and check them on a calculator. Your calculator is not going to do so well on this one, but that's okay. I'm going to show you how to do this, and the calculator is just really a backup, a double check. Now, all these powers of I rely on one fact. I squared is -1. That's the only thing that you've got to remember here. So how am I going to use that here? Well, I to the 22nd can really be written as I squared to 11th power. Why is that? Because when you have a power to a power, these exponents multiply. So 11 times 2, that's 22. So these things are the same. But here's the cool part. You know what's inside here, right? What can I replace I squared with? -1. And -1 to the 11th power, because this is an odd exponent, gives me -1. And guess what? That's it. That's your answer. We're done. Any questions on that one? Would you like to see another one? Okay. Here you go. I to the 60th power. We're going to play the same game here. You're going to start out with I squared to some power. Now the question is, what power? We'll take a look at the previous one. When I put a 2 here, I had to have something that multiplied by 2 to give me 22. So 2 times 11 gave me 22. So 2 times something is going to give me 60. What's that something here? Gentleman in the back, way to go. I squared to the 30th power. How about the young lady up front? What's I squared to the I squared equal to? Well done. I to the I squared to the 30th becomes -1 to the 30th. Because this is an even exponent, if I wrote out -1 times -1 30 times, you have an even number of negative signs, you're going to get a +1. Yay. Now, those first 2 cases are the easier cases, the nice cases. Not that the next 2 are that hard. It's just that we're running into a problem with I to the 31st power. And that problem is that 2 doesn't go into this very evenly, does it? So here's my solution. I'm going to split off one of these i's. This is I to the 30th power times I to the 1st power. And we're just going to kind of more or less ignore that I there and work with the even power. So I've got that I still stuck out here, but I'm going to concentrate on this thing. That's going to be I squared to some power. What power is that? What do I multiply 2 by to get 30. Yeah, thank you. 15. I squared, I hope you're getting used to this. I squared is -1. And -1 to an odd power is -1. -1 times I, we'll just write it as -I. Yay. And that's it. Again, the only fact that you have to rely on is that I squared is -1. I use that in all three of these examples here, and I'm going to use it in the following two. So let's take a look here. Oh, you know what? Before I do that, let's just take a look at things on the graphing calculator. There's nothing wrong with checking yourself on the graphing calculator. I encourage that. I want to see you get it right. Let's do I raised to the 31st power. Let's see what happens here. -I. Perfect. It's exactly what we got. Just make sure that when you do this on an exam, that you show me this stuff in between. I don't want just the answer. I've given you the answer, or at least how to get the answer. Let's try I to the 37th. Here again, running the same problem that we did before. And that is, this is odd. I can't just write it as I squared to some power because 2 doesn't go into this evenly. So like the last one, I'm going to split off one of those i's. If I split off one of those i's, how many of them are left? Well, if you said 36, then bravo to you. This is I squared to the 36 times I to the first. Remember, when you multiply things with the same base, you add their exponents. So 36 and 1 gives you 37. Beautiful. Here's where I can get to work, though. This is I squared to the 18th power times I. See if you can't finish it up. Then what? So it's going to be -1 to the 18th. And -1 to an even exponent is going to be +1 times I is just I. And that kind of completes our little list here. When you take and raise I to a power, you're only going to get one of four things when you're raising I to an integer power, I should say. So, wow. Okay. Well, how about this Mac Daddy up here? I to the 982 power. That's a big one. But it still works the same. Now, we're fortunate that this is an even power. And maybe you're looking at that going, I don't know. Well, you can take out your calculator. You can do it on Desmos, whatever works for you. 982 divided by 2 is going to be 491. Yay. That's what we needed, the 491. So see if you can't rewrite this. Some power of I to some power here. Pause the video if you need. Try and race ahead of me. All right. Hopefully you've got your answer. I squared to the 491, which would be -1 to the 491. Now, I don't need to do this on my graphing calculator. This is an odd exponent. If I raise -1 to an odd exponent, I'm going to end up with -1. Done. What if you did that on a calculator? Would that work? Let's find out. So I'll do I raised to the 981st power and bam, doesn't exactly give me what I was hoping for. Now, let's see. That's because I raised it to 980 first. I should have raised it to 980 second. But it's still not going to give me exactly what I was looking for. Now, it's not as far off as you might think, but it would take a minute or two to explain that. I'm not going to do the time on that now. So, yeah, there are limits to what your graphing calculator can do, but we don't need to rely on our graphing calculator for these types of problems. Now, the big reason that we introduced I here is because we're going to need it when we start solving polynomial equations. And let me give you a couple examples. Let's start out with an easier one, and I'll work with a harder one. Let's start out with x squared plus, we'll do minus 12x plus 37 equals 0. Hopefully, when you look at this, the first thing you try and do is factor it. And well, there's not two numbers that multiply with 37 and add to negative 12, so you're out of luck there. So you're kind of stuck using the quadratic formula. And I'll spare you singing this to my favorite fight song and just write it as negative b plus or minus the square root of b squared minus 4ac all over 2a. So in our case, a is 1, that's the coefficient of our leading term. B is negative 12 and C is 37. My suggestion is that you write the quadratic formula with a lot of blanks in it, and then go through and fill in the blanks. Now, why is the reason that I suggest you fill in the blanks here? It's mostly because it's very easy to make a mistake when you have these negative numbers. So, for instance, I get the negative of negative 12 plus or minus the square root of negative 12 squared minus 4 times a times c over 2 times a. Very easy to miss that double negative there. Okay. So let's see if we can't clean this up. That's going to be 12 plus or minus the square root of 144 minus, let's see, that's what, 168? No, 148. Now let's just double check it. 4 times 37, 148. All over 2. Combining like terms. Let's see. Something looks wrong here. And I know what's wrong. That was a minus sign. I turned it into a plus sign by accident. So it should be 12 plus or minus the square root of 144 minus 148 all over 2, which is 12 plus or minus the square root of negative 4 over 2. Square root of negative 4, well, here it is in kind of slow motion. Maybe you can do it all in one step for yourself. That's fine. Is the square root of 4 times the square root of negative 1, which is 12 plus or minus 2i over 2. Now, there's a couple ways you can simplify this. One way is you could factor out 2 from the numerator and say, all right, that's 2 times 6 plus or minus I over 2, and then cancel and get 6 plus or minus I. The second way to do this is to take 12 over 2 plus or minus 2 over 2 times I and simplify it that way, 6 plus or minus I. I kind of suggest that you know both methods, because a lot of times you're going to need to factor something out of a numerator and cancel part of it, in the denominator. What you can't do is cancel, say, the 2 into that 2, or the 2 into 12 and just be done. You can't cancel into just one of those. That's the only thing that won't work. Last problem, I promise. Let's see. How about x squared minus now plus 3x plus 6 equals 0. You should always look to see if this factors, or if you can use the square root property. Great. Chances are, a lot of times you'll end up using the quadratic formula. So let's just jump to the heart of this. A, B, and C, 1, 3, and 6. So it's going to be -3 plus or minus the square root of b squared, which is going to be 3 squared minus 4 times a, which is 1, times c, which is 6, over 2 times 1. So it's -3 plus or minus the square root of 9 minus 24 over 2. Now, I don't think WebAssign or myself is going to be very, very happy if you leave it like this. You need to clean up the square root of a negative number. Now, there's not a whole lot to it. I'll just write that as the square root of 15 times the square root of -1 over 2. Or better yet, for a final answer, let's come down here. -3 plus or minus the square root of 15 times I over 2. Now, one quick word about the I here. That I is not under the radical. So a lot of times I actually prefer people to write it like this, -3 plus or minus I times the square root of 15. Even though it's a little unconventional, it makes clear that the I is not under the radical. You will not take the square root of I in this course. That's a trig topic. So until you have me in trig, hang on. Good luck with this stuff. We'll see you soon.